Hey, good afternoon, and welcome to our session for today, Design of Steel Structures. And right now, we will be continuing our discussion with slip critical connection. So this is another type of bolted type connection wherein last time we discussed how to design and analyze yung bearing type connection natin. So slip critical connection is not so different from bearing type connection. Kahit nga yung mismong pag-analyze sa kanya, yung design process niya is almost the same nung sa bearing type connection natin. And meron lang tayo isang step na idadagdag para dun sa mismong design ng connection natin. And we will have an example of that. Okay? So to start, let's have a recall. So for bolted connections, so una, kinukuha natin yung bolt shear capacity natin based from table 7-1 or yung formula natin na ginagamit before. And then we also have, after verifying yung bolt shearing capacity natin, we are getting the value of the bolt bearing capacity using itong dalawang formula na to, wherein ina-identify natin what is the value of our edge distance and yung spacing ng bolts natin. And then we identify yung LCI and LCE. Then we use those formula dito sa RN natin para makuha natin yung bolt bearing capacity natin. And then we also discussed yung mga layout requirement for our connection. So for bolt spacing, we have the following limitation. For minimum, we have 8/3 ng dB. For maximum, we have the maximum between the minimum of 14T or 180 mm. And then for edge distances requirement, we have a minimum of based from table 510.3.4, ito yung metric niya. Pero kung ang gagamitin is English, we will refer dun sa J3.4 na table natin from last time. And then for maximum, we have a maximum edge distance na ang value will be a minimum between 12T or 150 mm. Okay? So, recall lang natin, nung sa bearing type connection natin, ganito yung design process natin. We identify the factored load, we determine the shear capacity of a single bolt, and then divide natin yung yung VRN na nakuha natin doon sa PU para makuha natin yung number 3 o yung number ng bolts. Then from dun sa number ng bolts, magkakameron tayo ng layout ng connection natin. So by verifying yung mga layout requirements natin, let's say yung spacing minimum tsaka yung edge distance minimum, we were able to have a trial connection. And then yung trial connection natin, chine-check natin yung bolt bearing capacity niya. Ngayon, kung hindi pumapasa yung bolt bearing capacity, doon tayo nagkakameron ng iteration or kailangan natin ng another set of trial connection based doon sa requirement o doon sa mga minimum distances natin. Ngayon, pagdating kay slip critical connection, yung item na babaguhin natin is yung number 2 lang. So, imbis na shear capacity lang yung kukunin natin, we will also be calculating slip capacity of the bolts. Ano? So, for slip critical connection, magbabago yung number 2 and then we will be taking the minimum between the shear and the slip capacities. And then, right after that, the same process will be adopted on all of the succeeding steps dun sa design natin. Okay? Pero before going dito sa design process of bearing type connection that considers both the shear and slip capacity, let us first define kung anong meron kapag slip critical yung connection natin. So a slip critical connection is a type of steel connection where the load is transferred between connected members depends on friction rather than bearing. So, di ba, last time we determined already yung lahat ng actions na nangyayari dun sa plate natin once na connected siya by a bolt. Meron na nangyayari, kaya nga meron tayong bolt shear capacity. Ibig sabihin, kinukuha natin yung limit state na pwedeng mapunit yung mismong bolt natin. And then we have yung bolt bearing capacity wherein we are considering yung pag-plasticize ng mismong hole nung hole natin and also yung face ng bolt natin. Kaya nagkakaroon tayo ng bolt tearing tsaka both nagpa-plasticize yung bolt yung area wherein nasa exposed siya doon sa face ng plate natin. And then yung isang sabi natin is nakadepend siya sa friction. Kaya nga, di ba pag binobolt natin to, iniikot natin yung mismong tornilyo dito sa bolt natin. Ang nangyayari, mas nagiging compact yung plate natin. So nag-i-introduce tayo ng normal force. Then kung may normal force tayo based sa formula ng friction, friction is equals to the coefficient of friction times the normal force. Ano, yan yung basic formula natin for friction. So since meron tayong present ng normal force based dun sa pag-tighten natin nung mismong bolt natin, nagkakameron siya ng friction dito sa portion na to. And that is yung kino-consider natin for slip critical connection. So commonly used siya sa structure kapag movement or deformation due to loads or environmental factors are expected. So kaya ito sa slip critical connection, mas ano siya, mas prevalent siya sa bridge structure, or kapag halimbawa alam mo na may possibility dumulas yung plate mo, yung connection mo, dun critical dun magki-critical sa slip critical connection. Okay? So important siya for seismic resistant design. Kasi nga, kapag halimbawa repeated yung loading natin, o tinatawag natin cyclic yung loading natin, may possibility na lumuwag yung mismong connection natin, yung halimbawa dalawang plate na pinag-connect natin, and kapag na-loose yung bearing nila with each other, o yung normal force na nag nagre-retain nung pag-bear nila with each face, doon nalulus yung possible limit state natin, which is yung slip critical connection. Okay? So, the nature of the connection ensures that the structural integrity is maintained even under extreme conditions. So, kahit halimbawa magkameron ng earthquake na medyo malakas, so dapat hindi siya magfe-fail agad-agad. Ano? Dapat it can sustain a remarkable value of loading and it will not suffer any deficiencies in the future. Ano? Yun yung ina-assume niya. So, to install a script critical bolt, yung ginagawa is dapat snug-tight daw siya. So, yung term na snug-tight, it refers dun sa tightening ng bolt natin to specified snugness of firmness. So sabihin yung level ng parang puwersa na yung pagkaka-push natin dun sa dalawang plate natin para mag-stick nila together. So in short, parang pag sinabing snug-tight, siya yung condition ng contact surface natin, or yun yung condition na yung plate natin are in direct contact with each other or with one another. And ang sinasabi dito, kapag naka-snug-tight yung ating plate, it allows for initial alignment of the connected members and ensure that they are properly seated against each other. So, yun yung kailangan yung faces ng plate natin o ng mga members na kailangan natin i-connect, dapat magkadikit siya para ma-generate o magkameron ng friction. Kasi yun nga dun nga kumukuha ng capacity si connection natin doon sa friction na nag-generate from the tightness na meron tayo doon sa dalawang plate natin na pinagdugtong. Okay? So snug-tight is a tightness attained with either a few hits of an impact wrench or full effort of an iron worker using an ordinary spud wrench. So ito yung definition niya naman kung ano yung workmanship na required for us to tell na snug-tight na yung connection natin. Okay? So may mga prescribed method on how we can actually pre-tension yung mga bolt o paano natin magiging snug-tight yung bolts natin. And here are some of them. Number 1 is yung turn of the nut method. So involves tightening yung bolt to a predetermined rotation or angle beyond snug-tight. So ibig sabihin, para masabi nating sufficient yung tightness ng plate natin or ano na siya, no? So kailangan lang, 'di ba ito, makikita nyo dito yung washer natin, mayroon siyang alignment dito. So para masabi natin siyang tight siya, very tight na siya, kailangan gagamitin natin 'to ng wrench, to-torque natin hanggang maging ganito yung itsura niya. Once na nag-align na sa lines yung mismong washer natin, it means na kaya na niya magbigay ng required tightness niya for the slip critical capacity to generate or ma-achieve na niya yung slip critical capacity niya. Okay, so that is turn of the nut method. Another method is yung tinatawag natin calibrated wrench method. So for this case, gumagamit naman siya ng parang device wherein may ginagamit siyang dial, okay, to check or chine-check niya lagi. Then makikita nyo, ito na mismo yung pag in-energize itong mismong wrench na to, siya na yung nagto-torque o nagti-twist nung mismong mga bolt natin to a predetermined value. So kapag calibrated na siya, um, ayan, so once na na-achieve na niya yung required na strength, titigil na lang siya dun or magki-click na lang siya. So ang mahirap dito sa calibrated wrench, once na halimbawa hindi mo natapos yung pag-fi-fix nung o pagta-tighten nung mga connection natin, kailangan on the next day, i-calibrate mo ulit siya bago ka mag-install kasi possible na hindi na siya calibrated. So, yun lang yung medyo downfall niya, no? Na you need to calibrate it daily before you can use it into another set of connection para ma-achieve yung tightness na required for the design. Okay? Another method is yung tinatawag na twist of control bolt. So, parang last time nakapag-present na ako ng video nito. So, nangyayari dito, kagandahan sa twist of control bolts, one side lang yung kailangan nating i-tighten. So, halimbawa, ito yung fastener natin. Once na itong instrument natin, pinasok natin yung itong sa may yung sa bolt na body, ano? And then once na yung gun pinasok na natin and then tinwist na niya, bali ang gagawin niya, puputulin na lang niya yung mismong portion ng body once na na-tighten na o na nag-click na yung gun doon sa desired na pretension na requirement. Kaya kapag natapos na yun, naging tighten na yung bolt natin. Both direction dito sa face na to and also dito sa face na to. Okay? And then another is yung direct tension indicator, DTI. So ito yung more common na ginagamit kasi mas ano siya, no, mas madali siyang gamitin compared with the others. Ang meron lang sa kanya, meron siyang ganitong mga washer na once na tinork mo na yung mga washers, yung mga tornilyo ng bolt, ma-achieve parang i-indicate na tama na siya once na pumutok na tong mga to. Itong mga to, siya yung maglalabas ng kulay orange na yun, which indicates na na-achieve na yung required na torque dun sa bolt mo para masabing tight na siya. So, kaya meron yung mga kulay orange na yun. Kasi nga, na-achieve na niya yung required na strength to generate yung required capacity for the connection to carry whatever loading it is designed for. Okay? So, ayan yung ilan sa mga prescribed method para i-pretension yung bolt natin kasi kailangan kaya nga pretension siya, kailangan magkameron ng friction. Kaya kung hindi siya i-pretension o hindi siya i-twist or i-connect agad, hindi magkakameron ng slip critical value o capacity yung connection natin. Okay? So, ano naman yung sabi ni code? So, how do we calculate actually yung value ng slip critical connection capacity natin? So, according to NSCP 2015, Section 510.3.8, ito daw po yung VRN natin o yung design slip resistance natin for a slip critical bolt connection. So, ito yung formula. Rn is equals to mu times du times HSC times TB times NS. Okay, so medyo mahaba kung tutuusin. Pero madali lang naman tong tandaan, kasi some of the terms included in that formula are may specific value na. Okay? So, first is yung yung DU na muna. Okay? So, DU is a multiplier na nagre-reflect yung ratio ng mean installed bolt sa pretension to the specified minimum bolt pretension. Okay? So, kung medyo broad yung ibig sabihin nito sa atin, ang sabi ni code, let us just use 1.13. Okay? So, ibig sabihin, ina-assume natin na yung ratio natin is 13% greater, na yung mean installed bolt pretension natin is mas mataas ang value kumpara do sa required na tightness niya. No? Yun yung ina-assume niya. Kaya, 1.13. Kung halimbawa, nakaset sa code na kailangan mo lang makapag-generate ng 50 kips dun sa pagta-tight mo ng mga washers o nung tornilyo ng bolt natin. Pero in reality, ang nagawa mong value ay 60 kips. Okay? Nung gumamit ka na nung any method na mention, nung nagpe-pretension tayo ng mga washers. So, ibig sabihin, mas mataas na yung value yung in-apply natin na pretension, and that accounts for this condition, yung DU. Wherein si code, sabi niya, 1.13 lagi yung gagamitin natin. Okay? And then we have HSC, or whole size factor. Okay? And for our case, that is always 1.0, yung for standard size holes. Okay? So we are not using naman any type of bolts o yung mga long slatted, yung oversized. Hindi pa tayo gumagamit nun. We are just using the basic or the standard size ng holes. Kaya 1.0 lang yung factor natin. Okay? And then for TB is a minimum fastener tension. Okay? So there is a table for this. So later ipakita ko yung table ng TB, ano? I will be providing the copy also of that. Kaya kailangan meron tayong value. So that is table J3. According to J3, table J3.1. Okay? So I think wala pa kayong copy nito in your part, pero I will be providing a copy right after sa NEO LMS na lang. Okay? So, okay. So where am I? Wait for a while, ha. Nahanap ko lang yung J3.1 ko para i-share ko siya sa okay. So, balikan natin 'to mamaya, itong TB. And we have NS, yung number of slip planes. So, ni-indicate naman 'to sa problem. Okay, ito. Itong NS, in-indicate naman niya sa problem. So, we just need to read yung problem kung ilan yung number ng slip planes natin. So, it may be 1, o parang katulad dun sa shear, ano? Kapag single shear lang siya, the single slip plane lang siya. Okay? And then, ano pa, yung mu, no? Yung mu is yung ating mean slip coefficient, o yung ating coefficient of friction na tinatawag. And meron siyang value. Okay? So, the mean slip coefficient may be class A or class B. Okay? So, kapag hindi binanggit sa problem, always assume na class A siya. Okay? Pero pag ang binanggit is unpainted blast clean steel surface or surfaces with class B surfaces, ito yung gagamitin natin. Pero unless stated otherwise, 0.3 lagi yung gagamitin nating value for mu. Okay? So, ayan. So, yung value nung TB natin, okay, yung TB do sa formula, dito manggagaling sa table na to, sa J3.1. So, this table is for metric and this table is for English, no? So, halimbawa, ang bolt natin size is 3/4. Tapos, ang sinabi na value ng ating fastener is group A. Sabi mo, di ba, pag group A, that is 8325 volts, ibig sabihin 28 kips yung value ng pretension na gagamitin natin for our formula. So, dito sa formula lang to. Okay? So, sa substitute na lang yan dito. Okay? So, may another grouping na binabanggit sa code. Okay? Ilagay ko na lang din. So, minsan sinasabi na group 120. Pag sinabi sa problem na group 120, that pertains sa A325. Or group A lang din. Okay? Or kapag sa problem sinabi na siya ay group 144 or 150, that is A490 naman. Or group A ito ay group B. Okay? So, you just need to be familiar dun sa bagong grouping natin. Pag binanggit sa problem ng 120 siya, kapareha siya ng group A na A325. So, ito yung gagamitin mong column. Kapag group 144, group 150, ito yung gagamitin natin column o yung group B natin. Okay? So, paano natin ngayon kakalculate yung resistance ng isang bolt, ano? So, solve natin dito. So, nakalagay, what is the design slip resistance of a 3/4 diameter A325 bolt? Okay? So, kailangan natin, diameter ng bolt is 3/4. Okay? Inches. And then, meron tayong A325 na bolts. So, kung A325, meaning siya ay group A. Okay? Then, assuming class faying surface, kulang to, no? Class A. Okay? So, assuming class A daw, okay? And only one slip plate. Okay? Yung N natin, NSP. Tama ba yung formula ko? NS lang pala, NS. Okay? NS daw is equals to 1. Okay? And then there's no filler plates present. So pag no filler plates present, yung formula natin for Rn is as is tayo. Mu and then multiplied by du. Okay? Du, HSC, TB, and NS. So no filler plates present. So HSC natin equals to 1.0 din. Okay? So du natin according to code kanina 1.13. And then ano pang wala natin? Yung mu. Okay? So for class A, ang mu natin is equals to 0.30. Okay? So TB natin, ngayon, pinapangarap yung TB. So pupunta tayo dito sa J3.1 and then for 3/4 group A, that is 28 kips. Okay? So 28 kips. So we have TB is 28 kips. So substituting this value, we have 0.3, 1.13, 1.0 times 28 kips times 1. So ang Rn natin is equals to 0.3 times 1.13 times 1 times 28. That is 9.492 kips per volt, no? Yan yung per volt na value. That is Rn only. And para kay slip critical connection, ang phi natin ay equal sa 1.0 and ang omega natin ay equal sa 1.5 according to the code yan. So ang phi Rn natin will be the same value, 9.492 kip per volt. And then, yung ating Rn over omega, yung ESD natin, will be 9.492 divide natin by 1.5. That is 6.328 kip per volt. Okay? So that is the value of this diameter. Okay? And katulad po nung ating ginagamit for bearing type for shear capacity natin, ay meron din table na gagamitin tayo. So, given daw po ba yung 0.3 na mu? Yes. Basta pag sinabing class A, dito no, pag class A yung surface, okay, sinabi naman class A, mu is 0.30. Pag class B, 0.50. Okay? So, ito. So, may table na ginagamit and that is table 7-3. So I will be providing the copy of this table 7-3 and makikita nyo slip critical connection, available strength in kips. Okay? Pero ang nakalagay dito sa 7-3, class A lang na surface. So class A lang yung nakalagay sa kanya. Only class A fairing surfaces are considered. Kung kailangan mo ng value for class B, yung makukuha mo dito sa table na class A, multiply mo lang daw na 1.67. Then both single and double slip conditions are considered. So halimbawa, yung kinalculate natin, that is a standard. Okay? Standard yon, tapos single plane lang tayo, 3/4 tayo, tapos ito yung value daw dapat nung ating VRN. And as you can see, that it is the same value that we have calculated dito sa previous slide, which is 9.492. Yung nasa table ay 9.49. Okay? So, ibig sabihin, you don't need to calculate yung slip capacity, bolt slip capacity from the start, ano, katulad nitong ganito. Ang gagawin natin, titingin ka lang din sa table na 7-3, katulad ng ginagawa natin sa 7-1, and then just identify yung mga parameters na required natin. And then, for our case, kailangan natin alamin kung group A o group B ba siya, okay? Tapos anong class ba niya, and then, kamusta yung kanyang, yung loading plane niya, siya ba ay single o double slip condition, and then yung diameter natin. And as you can see dito, kung ano din yung nakalagay sa table J3 natin para do sa T sub B natin, yung sa pretension, yun din yung nakalagay dito. So, 28 kips, no? So, ibig sabihin, pwede mo din gamitin yung 7-3 kahit wala ka nitong table na to. Okay? Ibig sabihin, for 7/8 na bolt, okay? Diba dapat pag group A, dapat ang sagot natin ay 39. Pag tinignan natin doon sa table kanina, for 7/8, siya ay 39 kips. So, kahit wala na tayo nung table J3-1, masosolve natin yung value for the pretension o yung T sub B na gagamitin natin for our formula na to. Okay? So, yun po yung usefulness ng table na to. Okay? Okay. Next. So, with that, I think we can now decide. Kasi sabi ko nga, isa lang na dagdag doon sa process natin. Nadagdagan lang tayo ng nung pag-identify ng bolt slip capacity natin. So, let us have a sample problem. Design a slip critical connection using the following data. We have a dead load of 65 kips, live load of 115 kips. We have group 150, 3/4 inch diameter bolts, A572 grade 50 steel, then use minimum spacing. So ito yung given na plate sa atin. We have a plate na merong 9-inch width and 3/4 na thickness. And then single lang siya. Okay? So doon sa step natin, kapag ni-recall natin yung pagde-design, ito balikan natin saglit lang. Ito yung step natin. Una is determine natin yung factor load. Okay? And then, next, determine natin yung slip, bearing and slip capacities natin. Okay? So, let us have yung first step natin. First step natin, calculate yung factor load natin. PU is equals to 1.2 PD plus 1.6 PL. Okay? Let us substitute 1.2, 65 kips plus 1.6 times 115 kips. So, ang PU natin is 1.2 times 65 plus 1.6 times 115. That is 262 kips. Okay? So, that is our applied loading or yung ultimate load natin from our combination. Okay? Next, for number 2, we need to calculate dalawa, no? Kailangan natin ng bolt shear capacity. Okay? And kailangan natin ng bolt slip capacity. Okay? So, dun muna tayo sa letter A, sa bolt shear capacity. Okay? So, dito ko lagay sa side. Bolt shear capacity. So, ano yung ginagawa natin ulit sa bolt shear para makuha natin yung capacity ng single bolt. Okay? Diba, ang unang ginagawa natin, alamin kung anong group niya. So, nakalagay sa atin is group 150. So, sa group 150 is the same ng A490 or group B. Okay? Group B tayo. Tapos, ano siya? Single o double shear. So, since isang plate lang naman to, nalalagyan natin ng bolt. So, single shear lang siya. Okay? And ano pa yung inano natin? Yung included yung thread, tsaka excluded. Kung walang binanggit, we assume na included yung thread natin. And then, we take single shear condition. Okay? And then we have dB is equals to 3/4. Ano pa ba yung required natin? Yun lang, ano? So, pag meron na tayong itong detail na to, pwede na tayo pumunta ng table 7-1. Okay? So, table 7-1, kung mabalikan natin, where is it? Okay. Punta tayo dito sa table 7-1 for a while. Okay. Ito. Table 7-1, di ba ito yun? Yung kung familiar pa kayo. So, ang condition natin, group B. Tapos, kapag walang binanggit, included tayo ng thread. And then, we have 3/4. And then, LRFD tayo na single. That is 22.5. So, lalagay ko na dito, ha? So, VRN, V is equals to, sinusulat ko lang before ko ibalik yung 22.5 kip per bolt. Okay? So, medyo natagalan kasi tayo mag-solve nung ganito, no? Kaya, baka nalilimutan na yung pagkuha nung bolt shear capacity natin. Okay? Pero yun yung mga condition natin. So, balik tayo doon sa PowerPoint natin. Okay, so ito. So ito yung nakuha kong capacity, 22.5 kip per volt. Okay? So may okay na tayo dun sa volt shear capacity. Kasunod natin ngayon is yung volt slip capacity naman. Okay? So for volt slip capacity, ano naman kailangan natin? So ganun pa din, kailangan natin ni group 150. Okay, so ibig sabihin group B tayo or A490. Pero ano yung tinitingnan natin? Ngayon, kailangan lalagyan natin kung naka N or ang binabanggit natin sa kanya is uh, included or excluded. Ngayon lalagyan natin sa kanya SC to indicate na slip critical siya. Tapos naka-single slip plane tayo kasi single lang din to. Okay? Ibig sabihin, dalawang plate lang yung pinagbe-bear natin. Kaya single slip plane lang tayo. And then, kung binanggit ulit, pag walang sinabi, class A tayo. Yung faying surface natin is class A. Okay? And then, yung dB natin is 3/4. Okay? So, balik tayo dun sa tables, 7-3 naman. Punta tayo sa table 7-3. Okay? So, this is table 7-3. So, makikita nyo yan, may group A tsaka group B. So, group B tayo. Dito tayo sa group B. So, class A tayo. So, fee natin ay 0.30. And then, hole type natin, standard. Loading type natin, single slip lang tayo, S tayo. And then, 3/4. And then, yung ating value ng VRN is 11.9. Okay? So, lagay ko na lang sa slide. VRN, tapos SC naman for slip critical is 11.9 kip per volt. Okay? So, yun yung ating value naman for slip critical capacity. Okay. Going back to sa slide natin. Then, so, ito yung value natin. Ito yung na-calculate natin dun sa isang table, 7-1. Ito ay table 7-1. And then, this is another naman para doon sa volt slip capacity natin, table 7-3 naman yan. Okay? And alin daw yung kukunin natin governing sa kanya? According dito sa definition natin from the previous one, nasa na yan? Dun sa steps. Sorry. Ayan. The take minimum of the shear and slip capacities. Okay? Kasi nga, gusto natin yung critical. Okay? So, dapat yung unang mag-o-occur na value, yun yung kukonsider natin sa design. Kaya, yung minimum yung kukunin natin. For our case, our minimum capacity would be yung 11.9. So, ang magiging VRN natin is yung 11.9 kip per volt. Okay? Yan. So, 11.9 kip per volt tayo. Okay? Next, for step 3, compute the required number of volts. Okay? So, para makuha yung number of volts, kukunin lang natin yung PU, divide natin doon sa VRN na nakuha natin dito. Okay? So, kuha tayo ng another slide. So, step 3. So, we have PU is equals to 262 kips. And then, we have VRN is equals to 11.9 kip per volt. Okay? So, to identify yung number ng volts required, number of volts is equals to PU over VRN. So, we have 262 kip over 11.9 kip per volt. To cancel to, pag kinalculate natin, that is 262 divided 11.9, that is 22.02 volts. Okay? So, isa-say natin 21 is medyo mahirap gawa ng arrangement sa 21, pero hindi naman imposible. So, 23 rather, kasi 22 na to. So, maganda, gawin na natin say 24 volts. Okay? So, 24 volts. So kung 24 volts, ano mga kailangan natin satisfy dun sa arrangement natin? So kunin natin yung S-min natin, okay? S-min is magagaling dun sa value ng ating dito, no? Minimum is 8/3 ng dB. Okay, that is 8/3 ng dB. So that is 8/3 of 3/4. So cancel, that is 2.0 inch ang minimum spacing natin. And then for minimum edge distance natin, that is based sa dito sa table na to, 510.3.4. Kaso this is for metrics, ano, wala tayo ng para sa English dito sa slide. So allow me to share yung table na pinrovide ko sa inyo before, table J3.4. Okay, going dito. Ayan, so table J3.4, minimum edge distance. So bolt diameter, tingnan natin si 3/4. Ang 3/4 katapat niya is 1 inch. Okay, so 1 inch yung ating minimum edge distance. Okay, for a while, 1.0 inch. Okay, so going back doon sa ating okay, so ayan. So yan yung mga minimum natin. So doon sa 24 volts, ano yung mga possible arrangement natin? Okay? So 24 volts, pwede tayong mag-arrange ng 3/8. Okay? Ibig sabihin, tatlong rows na tigwa-8. Okay? Pwede ding 6/4, 6 na tiga-4, or 8/3, pwede, no? Tatlo na tiga-8/3, or 4/6. Okay? Or 8/3. Okay? Pero, di ba imagine, yung ating plate is ganito yung itsura. Okay? Meron siyang, di ba doon sa dimension natin doon sa given, ang dimension niya is, width niya is 9 inches lang. Okay? Ngayon, kung ang i-provide natin, okay? So, kung halimbawa provide natin is 8/3. Okay? Halimbawa yung 8/3. So, ibig sabihin, 8 rows na tigtatatlo. Okay? Tigtatatlo lang na 8 rows. Ganyan, na 8. Ano mangyayari doon sa spacing natin dito? Masyadong malaki naman, ano? Tapos, sa haba tayo dito. Okay? Which will be a problem. Kasi sabi nga natin, ayaw naman nating sobrang haba nung connection natin. Kasi, pag haba niyan, yung cost ang problema natin. Okay? Kasi kailangan natin ng more plate material. Okay? Kaya medyo questionable itong 8/3. Okay? So, wag muna natin consider si 8/3. Si 3/8. Okay? So, tatlo na tigi-8. Okay? So, imagine nyo, 1, 2, 3, 4, 5, 6. Ayan, kulang. Okay? So, 8 na magkakasyahin natin ng 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So, bali ilang set ng ganito? Bali tatlong set para maging 24. Okay? Yan, nakaganyan siya. Kaso ang problema, sabi minimum natin na spacing is 2.0. Ngayon, kung 2.0 to, 2, ilan na yung total agad nito? Okay, 1, 2, 3, 4, 5, 6, 7. That is 14, which is exceeding na agad dito sa 9 inches natin. So, hindi siya pwede. Okay? So, ibig sabihin sa 3/8, cannot be din. Okay? So, kaya hanap ka ng ibang layout ulit. Okay? Si 6/4. Tingnan natin si 6/4. So, 1, 2, 3, 4. Tapos 6 set na ganyan. So, medyo mahaba yon, no? I-check muna natin yung 4/6. Okay? 1, 2, 3, 4, 5, 6. Move lang natin ng konti. Yan. So, bilangin natin to. So, we have 2 inches dito, another 2 inches, 2 inches, ito sobra nga. Sobra din pala to. Okay? So, dito pwede. Si 4/6 ay hindi pwede. Okay. So, 6/4 tayo. So, 1, 2, 3, 4, 3, 4, 1, 2, 3, 4, 1, 2, 4, 1, 2, 3, 4. Okay? Pag kinalculate natin, this is 2, this is 2, this is 2, tapos 6 na yan, 9 minus 6, that is 3. So, pwede natin gawin, tig 1.5 na lang. So, papasok siya dun sa limit natin na 1.0 dito. Okay? So, pwedeng i-trial natin si 6/4. Okay? Tapos dito, gawin natin minimum 1.0. Tapos ito, tigto 2 inches naman. Okay? So, ito yung magiging trials connection natin. Trial connection. Okay? So, pag may trial connection na tayo, ano yung sa number 4? Number 4 na ata itong trial connection. Ano? So, masa na yan? Ito. Okay, layout yung connection according to the prescribed requirement. So, okay na tayo sa number 4. Bolt bearing capacity yung check natin. 4 dito. So, bolt bearing na pala tayo. So, si number 4 actually is ito na pala. Okay? And then, number 5 tayo dito. So, bolt bearing tayo. So, for bolt bearing capacity, ano yung kailangan natin? So, di ba ang kailangan natin satisfy is Rn minimum between yung value ng LC, ano nga formula natin? 1.2 LC thickness FU, tsaka 2.4 dB T FU. Okay? Pero wala pa tayong mga value niyan. Kailangan natin ng LC. For LC, or for us to calculate yung LC, we need yung value ng ating S tsaka LE. So we have S is equals to 2 inches. LE natin is equals to 1 inch. Thickness natin is 3/4. dB natin ay 3/4. So, kailangan natin ng diameter ng hole din. Okay? So, pag diameter ng hole, that is dB plus 1/16. So, 3/4 plus 1/16, that is 0.8125. Okay? So, kunin natin sa LCI. LCI is yung calculation natin ng baka nalilimutan to. Ito yan, kailangan natin calculate yung LCI tsaka LCE. Okay? Kaya kinukuha ko din yung DH natin para dito. So punta tayo dito. LCI will be equals to S minus yung DH natin. So that is spacing 2 inches minus 0.8125. So LCI is equals to 2 minus yung answer. That is 1.1875. And then we have yung LCE edge natin. So that is yung value natin will be LE minus 0.5 ng DH. So that is 1.0 minus 0.5 ng 0.8125. O yung LCE, yung edge natin, that is 0.594. 1 minus 0.5, 0.8125, that is 59, kompleto natin, 375. Okay? Once na meron na tayo niyan, kunin natin yung grade ng natin. Meron tayong A572, grade 50. So, ang FY niya ay 50 KSI. So, ang FUI, 65 KSI. So, calculate na natin yung ano, yung values. So, yung ito calculate natin dito sa kabila, okay? So, halimbawa yung sa LCE muna, 1.2 LCE TFU. So, that is 1.2 times yung 0.59375 times thickness natin na 3/4 times yung 65. Okay? Kung ano man yung answer niyan. And then meron tayong 1.2 LCI TFU. That is 1.2 times 1.1875 3/4 of 65 equals. And then yung last, we have 2.4 dB TFU. So that is 2.4. Diameter ng bolt is 3/4. Thickness is 3/4. And then 65. Okay? So yung una, 1.2 times 0.59375. I-move natin sa kabilang page to. Okay? Yung mga values nito. So we have 1.2 times 0.59375, 3/4 times 65. That is 34.734375. 1.2 times 1.1875 times 3/4 times 65. That is 69.46875. Dito sa last, 2.4 3/4 times 3/4 times 65. That is 87.75. Okay? So that is in kips. Kips and kips. Okay? So para makuha, ang bawa, di ba sabi natin, RNE is equals to minimum ng 1.2 LC TFU 2.4 dBTFU. Okay? So pag RNE, ang kailangan i-compare natin is itong LCE na to, tsaka ito. So ano yung magiging sagot? Minimum. So of course yung 34.734375 kips. So lagyan ko ng marking ano. So halimbawa ito tsaka ito para pinag-compare. And then another one ko compare natin is itong value na to tsaka itong value na to. Okay, so that is RNI minimum between dito tsaka ito. So we have 69.46875 kips. Okay? So para makuha natin yung RN, kailangan natin yung number ng bolts sa edge times RNE plus number ng bolts sa interior RNI. Okay? So ito yung ating trial connection. Ito yung ating loading nandito. So ito yung ating edge bolt. So we have 4 na edge bolt. Tapos meron tayong 20 na interior bolt. So edge bolt natin is 4 times RNE 34.734 375 kips plus 20 ng 69.46875 kips. So RN 4 times 3, 4, 734, 375 plus 20 times 69.46875. That is 1528.3125 kips. Okay? That is the nominal capacity. So ang VRN natin, VRN, so again, pag bearing, bolt bearing, that is 0.75 nung RN. So times 0.75 lang natin, that is 1146.234 kips. Yan yung VRN natin. So pag pinakuha lang si RN over omega, so divide lang natin ng 2 yung ating nominal by 2.0. So divide ng 2. So we have 764.156 kips. Okay? So ibig sabihin ito yung bolt bearing capacity natin. Okay? And comparing that with our PU, that is way greater than sa PU natin. Therefore, Okay. So, therefore, trial connection, ah, adapt trial connection. Okay? So, ibig sabihin, pasado siya dun sa lahat ng requirement natin for bolt shear, bolt slip, and then bolt bearing capacity natin. Okay? And ang magiging itsura ng ating connection is this one, ano? A 6x4. Okay? Again, dinagdag lang natin yung bolt slip capacity na value. So, ang main observation is kapag nag-govern siya for pag slip critical yung connection, mas madami talaga siyang bolt. Kasi imagine, yung capacity ng slip is almost doble. Doble yung capacity ng shear dun sa slip, ano? Kaya magdodoble talaga yung dami. Kumbaga kung i-design lang natin siya for bolt shear tsaka bolt bearing, baka 12 pieces lang yung kailangan natin gamitin na connection. Pero since this is a bolt slip type connection, yun, mas madami yung number of bolts required for us to be able to pass yung requirement natin. So since yung value ng RN is napakalaki compared with 262, so okay na siya for bolt bearing. Okay? So ganyan po yung pag-calculate ng slip critical connection, yung design ng bolt based dito sa slip critical condition natin or limit state. Okay? Alright? So that ends our lecture for today. So if you have question, don't hesitate to message me sa GC natin para ma-address yung question. Alright? Thank you.